Okay guys, so we are going to talk about some of the fundamental concepts. Right? The first thing first I would like to understand from you, you used virtual machines, right? You get that idea, do you? Virtual machines, different from physical machines, but they are sitting on top of real machines like these guys, like you have, all of you have. And so a VM, basically what you do is you have a physical box, you put your VM in there. You could put multiple VMs, right? Let's call this multiple VMs. You can basically divide the whole big box. If you have a big box, you can keep partitioning it into smaller pieces and use only this portion, right? Or maybe use this portion. However you divide the machine in smaller chunks, you can make use of that VM. If you have a really large computer, you can absolutely create a ton of virtual machines in there, like small little VMs. Now the problem with VMs today is that they are big. Like I wanted to give you this virtual machine image. It is a 6 GB image. It takes 10 minutes to copy and give it to you. Right? It's painful. And we are doing it locally. Imagine doing the same thing on the cloud somewhere, like you're transferring machines from A to B. It takes a lot of time, a lot of effort, a lot of energy wasted. So how do we solve it? And that problem is what Docker attempts to solve in a different fashion. So if you know what does a VM contain inside, what are fundamental layers inside the VM, what do you need to have once you have a VM? Can you tell me?
An operating system.
You need an OS, right? So in the VM you need an OS somewhere, right? And then on top of the OS you need something else, right? What do you need to get the applications up and running? You need some other layer, right, in between.
Libraries.
Some libraries, something like that, some runtime, some library of sorts, and then put your application on top. That's a typical VM setup, right? Now what Docker attempts to do is finds out commonalities. Commonality as in, if you have one VM, let's call V1, another VM called V2. To build this second VM, you need to have again the same OS, some runtime libraries, and some other custom things, and then your application number 2. And so if there is a commonality between this OS and this OS, you run it here and run it here. It's a redundancy thing, right? We want to cut down redundancy as much as we can, if we can. That's the attempt that Docker is trying to take and solve that problem by reducing repetition. I call it the Department of Redundancy department. Did you get the joke? So if you imagine a situation where you have this operating system similar to this operating system, commonalities, some runtime library here, some runtime library here, and some other additional things you might have that may be common to them, why not just use them together as opposed to repeating them and use it only one time? And then just put your custom things on top and plus the application to go along with. And by doing this way comes this new model which is called a container technology. That's what we are really discussing right now, is that you have an operating system at the bottom which is common to all the containers we will have. So at the basic layer you have a machine hardware somewhere, and then you will have the common operating system basically spread out. The whole machine is occupied by that OS at the foundation layer, right? On top you will put the common libraries that you might have, again in form of another layer. And then you carve out spaces on top of the common libraries. You might have some runtime, some libraries that are common to everybody, all the applications. What you would do is a scenario where your application number 1, app number 2, and other applications that require the same common components, you can reuse them. If we design a layered method of deploying things, and that's what Docker attempts to do in a layered file system fashion. And here if you need something custom, you can add, and that custom is available only to this application, not to this guy, not to these guys. And to visualize this in form of a picture that you saw, I would like to actually show you an example of a real running Docker machine right here. And we will be using a computer somewhere. Either it is here, right in this machine, or somewhere away from us in the cloud. So to both examples I will give you one at a time. Have you heard of a thing called VirtualBox software, which runs locally? VMware, Hyper-V, bunch of different virtualizations. These applications run on top of physical machines, just like they create virtual machines like we discussed early on here. So what I'm going to do is use one such software that I have it running here. It's called VirtualBox, that I have running a machine here already. That running machine that I have here is running right now, and let me illustrate the point by connecting to it. So on this terminal window, what I'm going to do is make it big, make the font a little bit big, and make sure that I log on to that machine by connecting to it through SSH. So I'm connecting to that machine SSH, and I got connected. What I just did is sitting on my Mac, connected to a virtual machine on my Mac, both locally. Let me draw the same thing in a picture form. What I just did was, on the Macintosh that I have a little VM, and I connected from this Mac over to this computer through SSH. That's what you just saw me doing. You're familiar with this idea, right? Connecting to another machine like this. So that box that I have running in the virtual, where did it go? Here. So this box is where I want to run Docker. Mac doesn't run Docker. It cannot. It doesn't support layered file system. That is needed to run a layered system that we drew here, right? Layer containing operating system, layer containing this, layer containing that. We have to create layered file system, and Mac doesn't do that. So we have to have a box containing a operating system that will support layered file system, like Docker will use Ubuntu as the OS in this example. There are other operating systems based on mostly based on Linux that support this kind of a structure, and support for Windows is coming sometime in 2000, I don't know when, 16 maybe? Yeah, something like that. So it will come whenever it does, and until that time this is a solution already available. And so what we are doing is, this box is running a Linux called Ubuntu, and I just connected from my Mac onto that machine. That's what I just did. Now to connect to a box, there are a variety of tools available. In order to create and configure that particular target box in form of a Docker container, a machine that can run Docker, I am going to use Docker Machine, which is an application, which is an open source application called Docker Machine. Let's see where it is. So I'm going to go there. Docker Machine, that's the application that I have installed, that I will be using to configure that little VM into a Docker engine. What does that mean? In the Mac, you have this little box, which is a virtual machine, by the way, because I'm all inside here, so I'm not connecting outside, just doing it locally. In here, I will install Ubuntu, and then configure this Ubuntu box using Docker Machine, configure that to become my Docker engine. And then I can use that box as a Docker box, where I can basically create containers, deploy them, and by the way, deploy entire ELK stack in 5 minutes and have it up and running. We can demonstrate that after this talk. I know you use ELK. ELK is a name of a Canadian moose. I'm just kidding. It is called Elasticache, Elasticache and Kibana and Logstash. Elasticsearch, not Elasticache. Elasticsearch, Kibana and Logstash. These three together become the Canadian Prime Minister. Sorry, the ELK.
What's the main advantage of using containers versus VMs, and what is the effort in architecting container versus?
So yes, I'll repeat the answer. I just gave that answer. So the idea is to reduce redundancy. So if you think about a classic virtual machine, you need operating system, you need some runtime libraries, you need some other things that may be needed for the application to run, and then you put your app on top. That's a typical virtual machine, right?
So it's like a full stack of the minimum stack.
Right, that's what is needed to get a complete virtual machine up and running. In case of a container technology, if you find that these things are repeated in every other app that you want to run, let's say app number 2, right? You have some other custom XYZ, which is different from this custom, so they're different. But this is same, and this VM, and so you have the whole pack. It's like, in my example, I was like carrying around a 6 GB VM image that I wanted to give it to her. It takes 10 minutes doing it locally. That's a burden I don't want to carry, because I am basically reducing my redundancy by getting rid of this piece. I want to not carry that thing, not carry the craft if I don't have to. Unless I'm using Windows, then I don't have a choice. Right? I have to put VM, and it has to have the OS, which is Windows, and then it has to have everything else. So there is no such solution available for Windows, but in Linux there is. So you can get rid of what is known as Department of Redundancy department, and then only deploy this or this, and because these things are common, and so you basically get some platform that will cater to a layered system where you can run the OS and common runtime libraries and some other common components, and then you carve out layers here. So this become container number 1, container number 2, container number 3, and you put your custom XYZ, custom ABC, and you are up and running. Much better. This is very lightweight. You're not carrying this overload for every little application you want to run. Right? It's like 100K, 50K. In fact, I can demonstrate an entire quickly. Let's see. So I was connected to the Docker machine through this SSH session. I'm going to come out of it and then go to a different folder, and in there I will see if I am actually connected through some magic. So hold on, please. Let me see if I can connect. Yes. Docker status. No, Docker ps-a. Yeah, nothing is running. Docker images. Yeah, there are some images. Let me make the font a little smaller. Yeah. So you see that in my example, I have some images already. There are 2 images loaded. I'm going to pull some new image, and the image I want to pull is going to basically represent this lowest layer to begin with. Right? I'm going to grab that layer. I want to get an OS called the BusyBox OS. It's a really tiny 32 MB OS, right? Really small OS. I want to get that. Here is how you get it. You say docker pull and BusyBox, and it will pull. It is pulling an image from the global registry the Docker company maintains, and by the way, it probably finished. It downloaded a complete OS just now, as you saw. Like it was, let's see how much the size was, Docker images. Now we have BusyBox, and the size was, virtual size was 1.1 MB. So very, very small machine image that we obtained. That we have like 3 OS images showing up here actually. If you look at, is it an eye chart? Let me make it a little big so you can see. I'm making it big and doing the command again. So you have Ubuntu, you have BusyBox and CentOS, 3 different operating systems showing up one after the other. They're not running yet. I will now run them. And this is connected to that virtual machine that has been configured to run Docker containers. So I'm connected to that, and I'm running it on that Ubuntu box. I cannot run it on a Mac. It doesn't work. So having done that, I want to now start some container and run some application there. The simplest application that I can think of is to say hello, right? Echo hello or something like that. Very simple. So I'll run that application, and you will see that a new container gets created, and it will say echo hello, hello, and then come out of it, terminate itself, all of that in a matter of microseconds. Imagine doing the same thing like carrying around a 6 GB file, giving it to her, start a VM there, takes 30 minutes. I don't know, there's some update and this and that comes along. Nothing like that. You will see happening it just right now. I will be doing that by saying Docker, please run this BusyBox, BusyBox, the one I have, and inside that BusyBox, please run echo hello. That's it. So run that BusyBox, run echo hello, and then when you're done, you kill yourself. That's this command. So let's see. It did, and it killed itself. How do we know it killed itself? Docker ps-a. Let's see what are the processes that are dead. We'll see that there is a BusyBox process that died 13 seconds ago, right? Let us see any running processes. No. -a means all. This ps-a, all. This ps or only live processes. So now we saw a process in this command we have here. Docker run BusyBox, whatever that we did. We'll do it again. Docker run BusyBox, and this time I want to run some interactive shell inside that container, right? So I can run bash, which is a shell, go inside the container, run it there, but then it will run it and then it has nothing to do, so it will finish and die and kill itself. So I want to run it interactively because I want to talk to it. So I'll say run IT, as in interactive, in a teletypewriter mode, so I can interact with it. And then I will run it and says bash not found, because bash, the application bash, doesn't exist in BusyBox. It is so small. So I cannot run it in BusyBox. It doesn't exist. So I have to run in a different OS. BusyBox is a 1 MB OS. You saw that, right? So I'll run it in Ubuntu, and it will run. And you saw that the Ubuntu container started and gave me a prompt, like just like that. It just came. And trust me, I am.
Semicolons in between so that we do bash and then echo.
I did not understand. Hey, how are you doing? Cool. I did not understand your question. Grab a seat.
So in these operating system commands, you can put a semicolon and chain the,
You mean to say pipe character?
well, you execute several.
Yeah, if you say semicolon, it becomes a new command after the first one finishes, but this is just one command.
Yeah.
This is all one command. We are saying run bash inside Ubuntu OS, run in the Docker container. So this Docker run it Ubuntu bash is one command. There is no semicolon involved, right? And so if you go in there in that OS, how do I prove that this is actually Ubuntu? It looks like Macintosh to you, right? I want to prove that this is Ubuntu. How do we know? So I'll say cat at c/*release. You see, it's Ubuntu.
One question, maybe this is.
It's okay. Questions are welcome. Yeah, no,
Like,
it's
do
okay.
we have to prepare our software for Docker by registering it or something?
Yes.
So that it knows
Yes.
how to run this?
Yes. Yes.
Okay.
Yeah. If it is your software, you have to
Yeah,
prepare.
yeah, if I write something,
Yes. If you.
just like Ubuntu is already
Yeah.
pre-made to that.
Yeah. Correct. But Ubuntu is like an operating system. I think you want to run an application software. In that case, you have to build an image to run your custom application. And you can do that very, very trivially simply. And I can illustrate that also.
The image should contain, so first you are setting up a server with Ubuntu and then installing the application.
So you're not actually setting up a server with Ubuntu. Somebody has already done that work. So what you're doing is basically taking a container and pulling Ubuntu. So you're just using it. Yeah, it just comes down. It comes down by saying something like, let me come out of it. I'll say Docker pull Ubuntu. It's already there. It just makes sure that it is latest. It updates itself and says already up to date. So I have to do nothing, and it does nothing, and then it is available for me to use Docker images.
This comes from the Docker Hub.
Correct. Or it can come from your own hub if you have your own hub.
If you want your own private registry,
You
have
can.
your own registry and it
Yes.
flows from that
Yeah.
registry.
Yes.
Really like that previous web services type thing.
It is microservices.
Right? At
Yes.
that point, right?
Yeah, it is that. It is exactly that. And so
But
you,
it is real software.
yeah, it is real. It is very much
It's a
real.
full software.
Yes,
It
yes,
comes
yes.
down to the container wherever
Yes,
you want to
yes,
put
yes, correct. And so you saw me
it. It's a
running,
unicorn and we are learning.
right?
One of the biggest things that Docker will solve, and you could probably attest to it, is if I build a Ubuntu based application
Mhm.
and package it into another container, then give it to you, all you have to do is load that container and it'll run.
That's right. That's
That way
right.
You don't have to say.
So distribution becomes easy.
Very
That's
easy.
right.
Right,
DevOps
right.
becomes very easy
Right.
because now you cannot say, oh, it worked on your machine, it doesn't work on my machine.
That's the fundamental problem, right? People used to blame it doesn't work on your machine. What's wrong with you, right, Shao?
So they remove all the configuration issues, everything.
Right. Configuration issues are taken care of
They
in a.
took care of the configuration issues.
In fact, if
Whoever wrote it
if you have your own application, you have to take care of the configuration issues yourself for your application itself, right?
Sure. Yeah.
And then your friend in your company or your partners in other companies may not have to worry about that because the thing will run exactly like you running in your laptop. It'll run the same way in some cloud, like in Amazon cloud or whatever,
So is this
Rackspace
used
cloud.
more for on-prem software or cloud? Which one?
Whatever you can run there will run wherever you want it to run.
I
So it-
understand from a usage point of view.
So I run like 3 applications already, and including an Elk Stack, which is my friend's favorite application apparently. This guy uses Elk Stack big time in his company. The idea is to run any application that you want to run, as long as it is running on some Linux OS, it runs in Docker container just fine. You have to write and make it work correctly. There is a concept called Dockerization of your application. You have to take care of that due diligence, and then it's okay. It doesn't matter whether it's on premise or on cloud or who cares, as long as it runs.
So how does the memory and space get split into these Docker?
Memory in
Memory and
File
space, it is shared. So your underlying machine has to have it has to provide the support.
Is it dynamic as the application grows bigger, whatever?
Yes, you can regulate those parameters. There is a concept called C group or control groups in Linux. Using that is what the foundation of Docker is. So it partitions according to what you decide. And so if the underlying machine doesn't have enough memory, then the container will not have enough memory. So that physical limitation already exists. You cannot overrule that. If there is no hard disk space, sorry.
Sorry, is it dynamic? So with a VM, you say this VM is 4 gigs and this much
Right.
hard drive space. With a container, is it scales only what it needs?
That's a good point. So when he ran Docker run whatever application, there are command line switches you can specify to say, this application only takes
Yeah.
this much memory and these many CPUs. There are parameters you can pass in in command line or environment variables to limit it. Because if you have a machine with 100 gigs of RAM, you don't want your application to keep growing
Yeah.
and push everybody else out.
The-
So you can limit it.
Yeah, very rightly said. And I would like to iterate one simple thing. Think of the word container. Very succinctly, the meaning is to contain itself, to limit itself, to put a boundary around itself. Think of it as a jail, literally. Like contain yourself, contain the excitement. I don't, but yeah, the idea is to contain the boundaries of resources that you can eat up, consume.
When you went into that Ubuntu container,
Uh-huh.
you typed free. It tells you how much RAM is free. What does that represent?
So let's see, let's do the live, right? I'm going to go there and say free. And so we have how much? 8 gigs of RAM, and because that's the size of the virtual machine,
Okay, of the.
the underlying box,
Okay, got it. The virtual box.
right?
VM
The virtual box VM has 8 GB RAM, and this physical box has more, but the VM is limited to only 8, and that's what's showing up.
You're using an Ubuntu VM with an Ubuntu container running within it.
Correct. Bingo. Yes, sir. And so let us come out of that. Bingo is the name of my dog. Yeah. This is how he looks like if you haven't seen him. Where is Bingo? Oh. Well, I'll get to Bingo later. Let's stick here. So what I was doing was this. So let's do another operating system. This time, instead of Ubuntu, I will say CentOS, and I am in CentOS. How do I know? Cat etc release, see it is CentOS, right? And I come out of it and I'll say docker ps-a, show me all the dead containers, and here they are, all of them dead. Right now there is nothing running, docker ps nothing, ps-a, these dead containers. You got that concept clear, right? The concept about the idea, where was that? Here. The concept was that we were able to put any operating system we feel like on top of the underlying box, which happens to be running Ubuntu, and it has been configured to create Docker containers. So that box itself, this VM, runs Ubuntu, and in here we were running Ubuntu and then ran the bash command in there. We ran CentOS and we ran bash here.
You
We
make a Windows container on top of that?
no, sorry. The reason is that you have to have the underlying kernel same. It has to be the same kernel.
So it couldn't be FreeBSD or something either then, right?
You can actually in FreeBSD you can run Ubuntu. They have made some advances, and so if you look at this company, they claim, I have not read the whole thing, but what's the name of the company? Joyent.
Oh, right.
Yeah, they have provided SmartOS, which is kind of BSD Sun-like machines, and on top they provide this Triton, and here you can run whatever container you like. Right, so those guys do it, and they run it like FreeBSD jail, which is an old technology. I mean, it's old as in maybe really old, like 20 years old, roughly. So back to what we were discussing is we were able to see how you can put an OS of your choice, as long as the underlying kernel is the same, you can do it. There are other variations to this. You don't have to use Ubuntu. There are newer Linux specifically designed to run containers are available from this group called CoreOS, that is very gaining popularity in terms of its use in deploying containers. So that's very commonly used these days. Now the CoreOS,
Where do you get that?
CoreOS.com, open source. And so the scenario here is you put CoreOS, and it's the really, really tiny core of the kernel that you need to get a container to work. And once you have this core running, you can then put CoreOS on the real machine, and then create your Ubuntu, CentOS, whatever, Red Hat, you bring whatever you want, and you put your applications and do whatever you feel like afterwards. Now, how do you actually construct an application, a given application? Let's look at some examples. If you want to run some app, you have to understand what does it require to make it work, like all the way up to the bottom. You need to know end to end, what will it take to make it run. To build an image, like I'm pulling this CentOS or pulling Ubuntu or pulling this and pulling that, how do I build my own image? That's a simple question people ask, right? If I want to build an image that I want to put in Docker registry or Docker Hub, and I want to pull my own image anytime I feel like, I can do that fairly easily by creating a concept called a Docker file, and then using that Docker file to build my own image. For example, this Cloud Genius site itself runs in a Docker container, and this container is based on an image, and that image is called, guess what? Cloud Genius. It's available for public download. Nobody uses it except me, but it's there. It's in public registries. I can go download and check it out. And so there are these Cloud Genius images available. There is a WordPress container, Nginx proxy container, data container, and a bunch others. How do I make and prepare these things? Just click on there and go read about how do I do it. And so here is the full description. How did I make my own container? Using this Docker file. What does the Docker file contain? Let's read. So it says the first line on the very top, from WordPress. It builds on the shoulder of giants. There is already a thing called WordPress. So I don't have to worry about setting up WordPress. I'm going to use it. Why do I have to waste my time? Somebody has done it already.
So will it automatically get the latest build of WordPress?
You can regulate. You can regulate.
Okay.
What you want to get, you can regulate. I want to get this or I want to get that. In my case, I want to get the latest. So I'm not specifying which version of WordPress. I'll just say WordPress. So it will get me the latest. So that's the first line. Next line is maintainer, which is me. Then I do a couple of things. And these things are needed for my application. They're not ordinarily needed. For example, in that line called MB string, I need multi-byte string support. This one. So I can run e-commerce. So I need that capability, so I can run e-commerce based capabilities. Like, if I want to buy a ticket on Expedia.com, I want to put a credit card, then Shahul can sell me a ticket. He's the guy who sells tickets to everybody, right? This guy runs their Hadoop cluster in Expedia, which basically knows everybody who travels on the planet. He knows who's traveling, who's getting a discount. He never gives me a discount. I never asked him for it. I know. So this MB string is multi-byte string support, not ordinarily included in WordPress. So I need to add that. So I include that in the Docker file description. Then next one, I need some cryptography, again for e-commerce. This is mcrypt, so I can use PHP cryptography, that module is needed, so I include that module. Zip, again I need this, so I add that. It is not included in the default Docker. How do I find out what is included in the default Docker? That's another question, right? How do I know what do they have? So I will go to Docker Hub and in there search for WordPress and then go to the official WordPress, and through there I will go to the GitHub link for WordPress. Where is that? Okay, here. And so in GitHub I can see how they built their image. This is their Docker file. It's a little bit more complex than mine, but let's see. They are building, again, they are standing on shoulders of some other people, right? They're standing on the shoulder of a giant called PHP.
In
And-
WordPress, you can add some plugins.
Oh yes.
So how would that work? Like, let's say you have your container and you have your WordPress coming from the giant WordPress, and then you added some plugin that's specific to you only.
Correct. It is for me,
Is that
right? Yeah.
related to-
If it is open source plugin, you are welcome to use it. You may not want it. You might. I don't know. So the model to basically operate in this domain is to understand how the machine images are built. So I'm looking at how the official WordPress image was built on top of the PHP Docker container. Line number 1. And then they did some things and done some things and all that. And then they have Apache running in the foreground in the container. That's what they did. So I'm taking my example, and in my example I am adding these elements that I want. And then I add my fav icon, which is this icon that you show when you visit this site here. This little thing. Yes.
Back to your script.
Okay. Here.
What is the difference between these like Docker PHP style install, like that versus the regular install? What are those two?
Even this install.
Yeah.
This is identical to this install.
Yeah.
Right, and what's the difference between like apt-get install?
Oh, okay. Sorry for rushing. So this is installing an existing script called mbstring in PHP, whereas this is actually getting a package called lib mcrypt dev. So it's a package for the encryption library as a part of the operating system, not PHP. Once I have that package in the operating system, this blue portion caters to the operating system level binaries needed for the PHP function to work correctly,
Wouldn't apt-get handle that dependency?
not for PHP.
Well, I think one of the things you do when you pull down a core image, make sure it's updated. So you're calling apt-get update to update all the binaries to the latest version.
Got that?
And then you install whatever you want on that image. It's you creating that layer. You're creating that next layer.
Cool?
Sure.
Questions are welcome.
Confused about the
So
difference there.
let me illustrate that point here. So the idea is, in any OS, like, if it's Ubuntu, then we use apt-get, right? If it is CentOS or Red Hat, then we use yum. If it is Windows, we use Windows Update, right? Something like that. So these update mechanisms are used to update the underlying operating system. In this example, where is that? This blue portion is updating the apt cache to begin with, so I can know from where do I get the libmcrypt dev piece from the Ubuntu repositories when I run apt-get install, which is this portion. This portion will grab the libmcrypt dev package from Ubuntu repositories, the apt cache, and then install the underlying operating system level software that is needed. The next line will install encrypt with PHP.
Right, I guess what I'm saying, if I was in Ubuntu, wouldn't I just say apt-get install like PHP_encrypt or something? There's some module, right?
Yes, you're right.
And wouldn't that?
You're
do
right.
that?
You're right.
Okay.
You're absolutely right. But in this WordPress container, they have defined certain helper scripts known as this.
So is that something you wrote?
No, WordPress guys wrote it for Docker.
Okay.
So they have defined this particular install script specifically for this container. I'm just using it to make my life easy.
Okay.
So you can see this pattern, this blue pattern repeating like 3 times. The MB string, the mcrypt, maybe the zip, and maybe one more. No.
And this
No.
splitting it up into these multiple runs is just arbitrary. You could have said like and Docker install mcrypt and Docker install zip or hyped it or something.
Correct. So in this example, I'm dealing with one item at a time, dealing with MB string there, mcrypt in these 3 lines, zip in this one line. That's it. So basically, each item that I'm dealing with, I'm separating them with a white space line, right?
But he's right. You could.
Yeah, you can.
You can
Yeah,
change.
yeah,
merge
totally.
everything up into
It
one-
becomes less readable, but sometimes recommended
Now, what if one of them fails? Does it go to the next one or does it abort the whole thing?
about the whole thing. So this is an example of a Docker file that you can use to build a Docker image, and you can call it whatever you feel like. As long as you're not colliding with somebody else's name, you can use the name. And so this is where I have the favicon and htaccess that I have defined. And if you go look at the other file itself, the favicon looks like here, and the htaccess looks like here. So simple Apache scripts that I want to include in the image so that it works for me. And then this ext file size, I'm just making sure that the upload sizes are bigger, not just 1 MB, 2 MB. So making the uploads easy for me when I'm updating the site or somebody else is doing it. So the fundamentals are taken care of like this. So this is a way to create a Docker file. Now, to take that Docker file, you can build, let me bring that GitHub that you saw, let me bring it locally so I can operate on it. So I am going to go there. Where did I keep it? There it is. So here, okay, hold on, I think let me go there again. Yeah, it pulled correctly. So here is the htaccess, here is the sizes 32 MB, the Docker file itself. The same thing I pulled from GitHub is actually, this is where I first created it and pushed to GitHub from here. So I just have a local copy. So what I can do is, based on this package, I can go back to my terminal. Oops. Go to my terminal, which is here. And in the terminal, I am going to list. So these files already exist. What I can do in using these files is to build an image based on my Docker file. So I'm going to not rely on the Docker Hub image that I already have, but instead build my own image. How do I build it? I will have to read that Docker file one more time and make sure that there are no mistakes. I think not. So then I can build it. So Docker build this thing. That's all it takes. Build this thing. And so it will build it. Docker build dot, meaning build the folder here. Look for the Docker file in this folder and build it. And by the way, when you're doing it, please give it a tag called omni212/WordPress and build it right here. So it will go step number 1, WordPress. It will pull down the WordPress container, pulling. And then do all the things that you saw in this GitHub. Where was that? Here. It is doing these things. Step number 1, pull WordPress. Line number 11 is happening right now. Let's go. It's doing it. So then it'll run this and then run that and then be done. So then you have a WordPress container ready.
What are all those hashes? Are those
Which hashes?
in the last page where it's downloading? Are those different streams that open up, or are those?
Oh, these hashes. So these are layers in the WordPress file, in the WordPress container that are being pulled down from the Docker Hub.
So they take, it's like BitTorrent, they chunked it out and then.
Now every line here is a layer. So run, layer. Another run, another layer. You do something, layer. So it's multi-layered. Anytime you touch the file system, you change something, layer. It's called COW, copy on write. You want to write something, you first make a copy and then write. So your underlying thing is already preserved. You're not disturbing, not messing with it. Cow. Holy cow.
So those are, each one of those is like a diff of the last change?
Yes. Yes.
So as you make changes, that list is going to grow. Is what
Yeah, it does. It grows. It does. That's one of the reasons why you can bundle up all these multiple run lines together in one shot, so you can reduce the number of layers. You can also compress down the layers if you want. Sometimes you don't. Sometimes you do. Depending on the business case, you can compress an image, or you want to keep it as it is. So you can see that there are lots of things happening right now because it is doing the MB string, mcrypt, and all that is compilation happening. So you can see it, oh, finished. And so it has built an image called B15FC91, whatever that number is. That's the container, new image ready. Its friendly name is Omni212. Let's go, Docker images. And we have Omni212 WordPress with the latest tag ready. So it was built 16 seconds ago. And I can push it to the cloud, Docker Hub, or my own private registry if I have one. And anybody else can use it. It's a replica of the Cloud Genius WordPress image that I already have there.
Like pretty big.
Yeah, 538.9 MB, right? So now in this, I want to make sure that I can send it to Docker Hub, right? So for which I would like to see if Omni guy is here. Hey, Manish, do you have a login on Docker Hub? Hope not.
Login to what?
Docker Hub, do you have an account already? Or I'll just use mine. I hope you don't mind. I'm going to encroach on your name.
Go ahead, by all means.
So I'll encroach your name. Is that okay?
Yeah, it's fine.
So I'll give it to you, the login. So yeah. So the idea is, if he's let's see whatever is easiest. So what I'm going to do is push this image over to Docker Hub, which takes a simple command as to Docker push basically, and then Omni 212 WordPress like that. It should go, and it says I'm going to push it, but access not authorized. So I have to log in. So Docker login, and that's where he would use his login name, but he doesn't seem to have one, so I'll use mine. And it will fail because my naming is not wrong, but let's see what happens. I think let me log in, see what happens. So I'm going to find my password, which is very difficult to remember because I have no idea what it is, nor do I care. But I'm going to copy it, and you cannot see. I'm going to paste it, and then I'm going to say, give my email address, and I succeeded in login, I hope. Yes. So after having logged in, let me push it and see what happens. It is not authorized because my naming is wrong. So I should rename that again by using the CloudGenius name, right? So I'm going to use the name again, which means Docker build -t CloudGenius / I'll call it meetup, and then dot. So it'll build the whole image.
Once you name it, you can't change it.
No. So you have to, it just built the whole thing
Oh,
because it basically created a replica and used a different tag. So it already knows what to do, so it reused it. So now we have a CloudGenius meetup, which is identical hash. The hash is same. We just added a tag. And now I can push that one with my own name. So say Docker push.
so right now you have these two images pointing the same place, if you will. But if you go into one of them and change it, will that hash change then?
The hash will change.
Okay.
If you touch it, your hash will change. And so this is being pushed, and so we are basically, I cannot push to Omni 212, but I can push to CloudGenius, so which is fine. I just chose a different name, Meetup, which has no meaning. It's WordPress, but whatever, you get the point. So what we just did is pushed an image. What I want to be able to now do is to understand where do you want that. This is like huge and complex territory ahead of us. So I want to understand what is your area of interest, and we'll dive in that direction. Meaning, you tell me which direction you want to go to in terms of live demonstrations. That's what all I do is live demonstrations with real open source technology. So you bring up an idea and I'll do it.
I'm a little confused here. This, I'm saying that they cannot connect to the Docker daemon.
Oh, I see what you're going through. What are you running there?
I'm just running a regular. So what I don't get is like, so I've got Vagrant up. I need to start. I'm a little confused about VirtualBox, Docker, Vagrant up. How do they all kind of work together?
Okay, good question. So I will answer that. What is going on is a machine-specific issue, and so a couple of things to address that issue. So first thing, what he is doing is, I want to illustrate what he just did. He has a Mac. And correct me if I'm wrong here. He is running Vagrant, which is in a VM. That Vagrant VM runs, I think, Ubuntu. I'm just assuming. And he seems to have installed Docker here. I don't know how, but please tell me. And then he's running into, is the Docker daemon running? Question mark. That's the question. Now
Well, I do Docker.
how did you install Docker here? How did you install? How did you bring Docker to this Ubuntu box? A simple solution to this problem is to use this machine. It's already there. It runs Docker, no problem. It is an Ubuntu box, and you can download from here.
Is that the one you're using right now? to demo
Yeah.
this?
And yes, you will need to use the GetSync application, which is a BitTorrent based application, but BitTorrent is legal. And I'm running it right here. Where is my BitTorrent? Where did it go? Here. Yeah. So I have these people, we have all these people who have downloaded the machines. So it's a long list. But this is my file system. BitTorrent is my file system. Like people use Dropbox and Google Drive and whatever things like cloud storage. This is storage without the cloud. It is P2P. So all my machines always are with me wherever I go, including on my phone, because of this technology. That's what I'm using. If you haven't heard of it, it is not open source, but it is a beautiful technology.
You wrote that?
Huh?
You said you wrote that?
No. I'm not.
What does that do? It's good.
Bram Cohen wrote it. He used to live in Bellevue. And he is the creator of BitTorrent protocol, which is famously known for piracy. But the torrent
He was in
protocol
jail.
itself. Sorry? Huh? No, he's not in jail. No. He's a big gun.
Nilesh, a big question.
Yes.
Why in the cloud, AWS or Google Cloud, spinning up a VM takes time. Why would the cloud providers not use Docker to quickly spin up?
They do.
They do?
Google spins up about 4 billion containers a day.
Okay. So
Yeah.
AWS, I think is
AWS also has Docker solution. It's called ECS, Elastic Container Service. So they have a new service.
EC2 is a VM,
ECS is not.
ECS. Okay.
So AWS ECS, that's the service that these guys have.
All the major cloud vendors have a container engine-based
Yes.
service.
Okay.
Azure has one, Google has a container service,
Yeah.
Amazon does.
So this is the EC2 container service from Amazon, and Microsoft also has Docker support. They give you Ubuntu or Linux VMs running Docker. Rackspace does, Giant Triton does, and another example that you will probably like is this company that is my favorite currently, DigitalOcean. These guys do not do containers, right? Do not. But watch this. Watch this demo. So the image that was pushing is pushed. So I'm done with it, right? So let me kill my Docker machine on the local VM. I'm going to get rid of it completely. Here is how I do it. Docker machine RM, bye-bye. So I don't have Docker anymore. I cannot, Docker PS cannot connect. So it is not accessible for me anymore. Now what I'm going to do is start a Docker container in a cloud, and let's see how efficiently can we do it in DigitalOcean. That's an example I would like to illustrate. So I'm going to open up a cheat sheet and see if we can start a new Docker container in a matter of minutes. So there we go. That's my cheat sheet. I'm going to run it and off we go. So it is going to connect to DigitalOcean, create a Docker container for me, and be back in 2 minutes. And I will have a ready functional container service in DigitalOcean. You can see that this thing that I started is basically started up a box in DigitalOcean. It's happening right now. You will see that a new machine is getting created. This one. It is actually getting built. In 30 seconds it will be ready. and once this is ready, it will run Docker and it will hook up to my Mac. So I can run Docker build, Docker run, Docker image, whatever I want to do on that DO machine wherever in San Francisco, sitting right in my terminal. A droplet is like a virtual machine, is like an instance, is like a funky name you can come up with. It's their marketing, right? It's the digital ocean, right? So in the ocean, this is a droplet. So they couldn't call it a piece of cloud in the ocean, doesn't make sense. So they had to use the word droplet. But droplet basically is a machine. So you see what he's doing is pushing out certificates to the machine out there and preparing Docker over there. And then once, well, yeah, it is done now. So it is telling me to set up my environment, which I will. And then once the environment is set, I can connect to it. Come on. Come on. Hello, respond please. This is what happens in live demos. It tells me it succeeded, but it doesn't. Go forward. Experiencing stormy conditions. It says that currently we are experiencing stormy conditions. The API is not available. Please raise your sails again shortly. Look at that ocean.
Is that a break time?
It's a break time. I think it's a good time to take a break. Yeah, makes sense, makes sense. So look at the error messages. It's all like totally in the ocean, right?
Yeah, it is.
Raise your sails again shortly.
Let's say it carefully.
On this
Maybe bring the
image,
sales down,
Yes.
otherwise it will be
what
gone.
is the root password? Does it update the guest OS, but then it requires root password to do that?
Let me come.
I installed your thing.
Oh, the root password is Cloud Genius. It says the password is Cloud Genius.
Oh my god.
Branding.
Oh my goodness. Take a break and we'll have pizza. I think pizza is here or not. That's what I heard. Let's check. Oh, it is here.